Welcome back everybody. For the final section here, we're going to talk about these things, folds. So we ask ourselves the question here. We learned about stress. What kind of stress do you think would cause rock layers to fold up, right, and look like this? Is it going to be extension, compression, or shear? So a fold is something that looks like this. It is a bend or warp in a rock, usually a layered rock, sedimentary rock. These are caused by compressional stress, and usually you get multiple types of folds right next to each other. Try to think about this and why that might happen. Now, just like we did with faults, we have to ask these questions. Where do folds happen, right? What about those four factors? Well, folds happen in the zone of ductile deformation. This is going to be deeper in the ground. Temperature tends to be hotter, deep below the surface. Pressure needs to be a lot. Rate of deformation, right? With faults, it was fast. With folds, it tends to be much more slow. Composition of rock can be anything, but typically you're going to see folds in sedimentary rock layers. These tend to be structurally a little bit more bendable than solid igneous or metamorphic rock. So the first type of fold we're going to talk about is the anticline fold, right? Anticline like an A. So you imagine, right, you take your rock layer, you push it together, and it forms up to make this kind of an A shape. Now, for now, that A shape is only visible looking at it from the side. What do you see if you take the bird's eye view and you look from the top down? Well, you would see this sort of barcode pattern, right? Alternating stripes. Now, if you know it's an anticline, you have to ask yourself, where are the oldest rocks? And here's the best way to remember this, instead of just memorizing it. You imagine, right, you have your rock layers, you have younger layers on top, older rocks on bottom. You take it and you bend it into the shape of a capital A. And now what happened to the oldest layers? They're in the middle. So you're driving along and you see something like this cut out of the road. You know that this is a fold, and you know because it makes the A shape, this is an anticline fold. Next is a syncline fold, kind of the opposite of an anticline, right? You see the S in syncline, and you remember that it kind of looks like a smile. Now here it's going to be completely the opposite, right? We've taken our rock layers and we compress them and they bend down into the shape of a smile. Alternatively, right, our other model, you imagine that you have your rock layers and here you bend them down. Well, here are the younger layers. They're going to be in the middle of the fold. So if you're out hiking, you see something like this, you know that it is a fold, and because of the smiley face shape, you know that this is a syncline fold. Now, if you remember, right, when I introduced folds, I said that the different types of fold usually come in combination with each other, and why is this? Well, we can kind of get a feel for it looking at this picture here. We have a syncline fold here, but if you follow it around, it starts to curve back and form an anticline. So we have an anticline-syncline pair in this photo. Sometimes you might see something that is like a half a fold called a monocline, right? Mono means one, cline is like fold, so one fold. Going to be very simple. We don't have to worry about where the oldest and youngest rocks are, just a bend in the layers of rock. What does this actually look like? Well, we have our parallel horizontal rock layers over here, and then we have this bend, right? This is the monocline. Now, there's kind of a common misconception, and we're going to clear it up right away. Anticlines don't necessarily mean mountain ranges. Synclines don't necessarily mean valleys. Okay, so let's look. We have these parallel layers that have been folded into these anticline-syncline pairs, right? Anticline, syncline, anticline, syncline. But because of the erosional pattern, right, you have some anticlines that form ridges and synclines that form valleys, as you would expect. But because of the erosion in other places, you can have an anticlinal valley or a synclinal ridge. In other words, anticline does not mean ridge or mountain range. Syncline does not mean valley. Now, you imagine we take a bowl and we turn it upside down. This is a dome. It's something that's like an anticline, but sort of three-dimensional going all around, right? Like the dome on top of a building. So all the layers dip, right? They go down away from the center of the structure in all directions. Now, a basin is just the opposite, right? It's like a normal bowl shape. It's like a syncline, but in three dimensions. And part of the reason why basins are important is because whenever you have a big bowl shape like this, it tends to be a very common place for sediments to be deposited. So a plunging fold. We go back to our paper model, right? We have our fold, and then we tilt it forward. And that tilting is called plunge. This is a plunging fold, just like in the diagram here. So it's very rare that folds in nature are perfectly vertical. Almost all of them are going to plunge to a degree. In other words, most of the folds out there look like this, right? So we've taken something that is a fold and we've plunged it in this direction, and now we actually have some of the curved pattern visible at the surface. It does not look like a barcode. There's kind of an important question here, right? If you saw something like this from the bird's eye view on the map, this sort of plunging fold, how could you tell if it was an anticline or a syncline? What you would have to know, the key piece of information, is the age of the rocks. If the oldest rocks are in the middle, you know it's an anticline. If the youngest rocks are in the middle, you would know it is a syncline, or a plunging anticline, a plunging syncline in this case. So there's this thing called the plunge direction. If we remember, we have our sheet of paper, right? We fold it into an A for an anticline. Now, if I'm going to plunge it towards the camera, right? What is it going to look like at the surface? Well, we would notice that it looks something like this, right? The direction of plunge is in the same as the top of the arch. A syncline would be the opposite. So if I flip this upside down, we make a syncline, and now I plunge it towards the camera. What is this going to look like at the surface? It's going to look like this, right? The direction of plunge is away from the arch. Now, the geometry of all of this can be a little bit confusing, especially if it's the first time you've looked at this. I would encourage you to go through this video again, slow down, make sure you understand each step and that you can visualize each step in your head before getting to the final part here where we put it all together. So, what are the big ideas here? What are the three types of stress? Extensional, compressional, and shear. What are those four factors that affect rock deformation? We can have brittle or ductile. It's based on temperature, how much force is applied, the speed that that force is applied at, and the rock composition. What are those three types of faults? Normal, reverse, and strike slip. What are the associated stresses? Normal is extensional, strike slip is shear, and reverse faults are compressional. And finally, what are those five types of folds? We have an anticline, syncline, monocline, dome, and basin. What do these look like on a map? Where are the older rocks and where are the younger rocks? That is all I have for you. There is no access code for this week. It's going to be a little bit different. Thank you for watching all the way to the end.